Hi everyone, I am Prachi Agarwal. Welcome to our channel Learn Competitive Programming with CodeChef. If you are interested in competitive programming and want to learn and master data structures and algorithms, then this is a one-stop destination for you. Every week we'll post CodeChef problem explanations, conceptual videos on various programming paradigms, and also conduct live problem-solving sessions. But before we actually get started, here's a reminder to hit the subscribe button if you haven't yet already. Great. Now that you have subscribed, let's get started. Welcome back to the course Introduction to Programming. In the previous video, we discussed all about relational operators, which were used when the answers to a particular question depended on a single condition. Like there, we took an example of finding out whether the number is even or odd. So we just had to check that the number is divisible by 2 or not. That is a single condition on which our answer depended. But now we are talking about a scenario when we have multiple conditions to consider in order to reach our answer. So in that case, when we have multiple conditions, we will have multiple Boolean expressions. Let me show you. Consider this example where it says that we need to input a number n and find out whether it lies in the range of 1 to 100 or not. And it is written both inclusive, which means that n can also be 1 or n can also be 100, and it can have any value between 1 and 100. So some of the possible values of n will be 1, 4, 7, 100 and so on. So any value between 1 to 100 will be valid. Now how do we check that? So for that, we will need two Boolean expressions. The first Boolean expression will be that n should be greater than or equal to 1. This is the first Boolean expression that we will have to consider, which will have to be true in order to find out that if it lies in the range of 1 to 100 or not. So n greater than equal to 1 ensures this particular condition that yes, n can either be 1 or it can be more than 1, but it does not ensure that n will lie within the range of 100, means it will be less than 100. This condition does not ensure that. So we will have to take one another condition which also ensures that n should be less than or equal to 100. So for that we have to take this other condition, n less than equal to 100. Now if we combine both these conditions, then we will be able to justify this question and find out for sure that n lies between 1 and 100 or not. But individually, these conditions are not sufficient because n greater than equal to 1 just checks that n is 1 or greater than equal to 1. And it can be 101, it can be even 200. So there is no check on the upper bound but only the lower bound of the condition. Now this n less than equal to 100, this condition itself only checks the upper bound that yes, n is less than 100 or not, but it does not check whether n is greater than 1 or not. So n can also be a negative value like -1, -2, and still this condition will return in true as the answer. So when both of these conditions are combined, only then we will be able to solve this question. Now take another example. Here we have to input a number and print true if it is a multiple of 10 or 6, else we will print false. So we have to check whether n is a multiple of 10 or it is a multiple of 6. So again there will be two Boolean expressions here. The first expression will check whether n is a multiple of 10 or not. So how do we do that? We already know this. We check the divisibility of a number by using the modulus operator. So if n modulus 10 is equal to 0, then it will be divisible by 10. For checking the divisibility by 6, we will have to check n modulus 6 equal to 0. Now it is given that if it is a multiple of 10 or 6, then in both cases our answer should be true. So definitely we will have to combine both these Boolean expressions in order to justify our question. Now, how do we do that? How can we combine more than one Boolean expressions together? We use logical operators to combine more than one Boolean expressions. The logical operators are logical not, logical and, logical or. Now, in order to understand these operators, we will see them one by one. First, we are going to see the logical AND operator. What is the logical AND operator? Logical AND operator suggests that if all of the conditions, all of the Boolean expressions that are used along with AND, if all of them are true, only then the answer will be true. Otherwise, the answer will remain false. Now, we will try to understand this with the help of two expressions. There is expression 1 and there is expression 2. And both these expressions are combined with the help of logical AND. When they are combined with the help of logical AND, we will try to check all the possible combinations of true and false values that these expressions can have. So these expressions on solving will return in either true or false. That is what Boolean expressions do, right? They can have only two values as the output, that is true or false. So we are going to see all the possible combinations of those values and see what will be the result. Now this representation that you see here, this is known as the truth table. It is known as the truth table because here we try to form a combination of all the true and false values, and according to that, based on that, we find our result, that what will be the final result of the entire expression, whether true or false. So for AND, as I already told you, that only and only if all of the expressions, or in this case both the expressions, have true as the value, only in that case the result will be true. Otherwise, for all other cases, the result will remain false. So if the value of expression 1 and 2 are false and false, then again the result is false. If it is false and true, then also false. If it is true or false, then also the result is false. Only in case when both the answers are true, the result will be true. So we use the logical AND operator in scenarios when we want that all of the Boolean expression values should remain true. The answer to all of the expressions should be true for us to have a valid condition. Now moving on to the other operator, that is the logical OR operator. In logical OR operator, it is the opposite of logical AND operator. In logical AND, all the values should be true in order for the result to be true. But in logical OR operator, even if for one expression the value is true, then it will result in the answer as true. So if there are two expressions, expression 1 and expression 2, and to combine them, we are using the OR operator. So when we are using the OR operator, again, we will use the truth table in order to determine all the possible combinations of true and false values and find out what will be the result. So for both false values, that is expression 1 and expression 2, both will have the false value, then the result will be false. And only in this case, the result is false. That means if all of the expressions have the value as false on solving them, then the OR result will be false. Otherwise, in all other conditions, you can see whether it is false or true, true or false, and true or true. In all these conditions, the result, the final result of the entire expression will be true. We use the logical OR operator in those scenarios when we want that out of all the conditions, even if one condition is true, then our entire result should be true. So I hope that you have understood logical AND and logical OR. Now logical NOT operator is used with just one expression. It does not use two expressions because logical NOT operator is just the inversion of a particular value. So if suppose an expression has the value false, then it will be changed into true. It will be inverted into true. If an expression has the value as true, then it will be inverted into false. So suppose a particular expression has value a greater than b. If a greater than b is true, then in that case the usage of this NOT operator will change the value into false. And if this value would have been false, then it will change it into true. Now moving on to the logical operator precedence. So the highest precedence is of the logical NOT operator. Then after that comes the logical AND operator, and the lowest precedence is of the logical OR operator. And if we talk about the overall precedence, that is, we have studied three types of operators: arithmetic, relational, and logical. So if we talk about the overall precedence or overall priority, then the first priority is of the arithmetic operators. Then the second priority is of the relational operators. And the third priority is of the logical operators. So if all of these three operators are present in a particular expression, then first we will solve arithmetic operators, then second we will solve the relational operators, and at last we will solve the logical operator. Now we will learn more about operator precedence in the later part of the course, but for now let us see how we can use these logical operators. So these are the examples that we took earlier in the beginning of the video. That the first example was that a number n has to lie within the range of 1 to 100. So we saw that we needed these two conditions in order to satisfy this question. Now we have to combine these two conditions, that is n greater than equal to 1 and n less than equal to 100. Now which logical operator will be used here, and or not? So definitely not. We cannot use the logical NOT operator because it is used with a single expression, which leaves us with and or operator. So if we use an or operator here, again, even if one of the conditions is true, then the answer will be true. But in this case, the answer will be wrong, because we want that both of these conditions should definitely be true. Only then the answer should be true. Only then it will ensure that n lies in the range of 1 to 100. So we have to use the AND operator here. And if we use the AND operator here, we will be able to ensure that n lies within the range of 1 to 100. Now look at the second scenario where we had to check that if n is a multiple of 10 or it is a multiple of 6, then we have to print true, otherwise we have to print false. So these are the two conditions: n modulus 10 equal to 0 and n modulus 6 equals to 0. Even if one condition is true, means one of the divisibility comes out to be true, then in that case the answer will be true. So according to the logical operators, when we use an OR operator, then we can get this scenario that even if one condition is true, then the complete answer will be true. So here we are going to use the OR operator. So this is how we decide that which logical operator should be used. Now we will try to represent these examples in the form of flowchart. Now in terms of flowchart, nothing changes because multiple Boolean expressions, they combine with the help of logical operators to form one single Boolean expression. Because these individual Boolean expressions will also result in either true or false, and when these true and false values are combined using the logical operators, they in turn result a value which is either true or false. So that is why we can write this in a single decision box. And we already know that a decision box can just have two values, that is true or false. So if n greater than equal to 1 and n less than equal to 100, it is true, then we just display true, and if it is false, then we just display false, and both of these will result in the end of the instruction cycle. So that is why the arrow points to end after both these display process boxes. The second question, where we had to find whether n is the multiple of 10 or 6 or not, same way, just like in the previous example, same way the entire condition that we discussed, we have written in a single decision box, and just that if it is true, then we are displaying true, if it is false, then we are displaying false, and this marks the end of the instruction cycle. So the pointers point to the end of the instruction cycle, and as you can see that nothing has changed in the first half of this flowchart. So the flowchart will be made in the same way as we were making when we were just using the relational operators. So guys, I hope that you have understood logical operators very well, and if you did, then please do like the video. Now For you to practice, I have given 2 questions here for which you need to draw a flowchart. It will help you understand how to form expressions using the logical operators and also help you understand how to give instructions in a proper manner. So question 1 says that input a number and you have to print true if the number is even and it is not divisible by 3. Otherwise, you will print false. Pretty easy question, right? And question 2 says that input a number and check whether it is divisible by 7 or 5. If it is divisible by either 7 or 5, then print twice the number. Otherwise, you have to print the fifth multiple of the number. So I hope that both the questions are clear to you. Here I am not trying to give you any hints that how the expression will be formed. So try this on your own, and if you are not able to understand anything, then you can refer the description box below where you will find the answer to both these questions. If you have not understood anything, then please post it in the comment section and we'll be happy to help you. Also, if you have any feedback regarding the video, then please post it in the comment section.